To determine a neutral grounding reactor for a generator, firstly calculate the fault current. Determine the maximum fault current, either ground fault or phase-to-phase, that can flow through the generator. This calculation requires a short circuit study. Secondly, determine the neutral grounding method. The common methods are solid grounding, where the fault current is theoretically infinite; resistance grounding, where the fault current equals the fault voltage divided by the grounding resistance; and reactance grounding, where the fault current equals the fault voltage divided by the grounding reactance. Thirdly, calculate the grounding impedance. For reactance grounding, calculate the reactance of the grounding reactor using the formula X equals V divided by I, where X is the reactance of the grounding reactor, V is the fault voltage, and I is the desired fault current. Fourthly, select the grounding reactor. Choose a commercially available grounding reactor that meets the calculated reactance and current rating. Now let's look at converting a 60 Hz system to a 50 Hz system, focusing on high voltage substation changes. Firstly, address the lightning arresters. Replace existing lightning arresters rated for 60 Hz with those rated for 50 Hz. Secondly, consider the potential transformers. Replace the potential transformers and adjust their ratios to match the new frequency. Thirdly, examine the current transformers. Replace the current transformers and adjust their ratios to match the new frequency. Fourthly, regarding the disconnectors, generally no changes are required for disconnectors. Fifthly, assess the transformers. Determine if the transformer can handle the lower frequency. If not, replace it with a new transformer rated for 50 Hz. Sixthly, address the fuses. Re-evaluate the fuse characteristics and replace them, if necessary. Seventhly, focus on the relays. Replace the relays and adjust their settings to match the new frequency. Specifically, consider these relay types. For overcurrent relays, adjust the reset time and trip characteristics. For differential relays, adjust the reset time and frequency response. For distance relays, adjust the zone boundaries and reach settings. Other considerations include generators, capacitor banks, motors and loads, and metering. For generators, determine if the generators are capable of operating at 50 Hz and make necessary modifications such as governor settings and automatic voltage regulator adjustment. For capacitor banks, verify that capacitor banks are rated for 50 Hz operation and adjust their sizes if necessary. For motors and loads, assess the impact of the frequency change on motors, pumps, and other electrical equipment. For metering, replace or recalibrate meters to reflect the new frequency.